Hi, this is Julia, and welcome back to part 2 of our Made Digital project working in Unity with 3D animation. Last week we made a robot. This week we're going to take our robot, we're going to color it, we're going to make a ground underneath the robot, and then we're going to make our robot move. So the first thing to add color, we're going to create a new folder. We're going to go up into the top menu of Assets, click on Create, click on Folder, and we're going to call our folder Materials. And with the Materials folder still selected, we're now going to go back up to the Assets folder on the top. So click on Assets menu, click on Create, and click on Material. You want to call this one iBlack, EYEBLACK. And then once that material is made, we're going to go back up into the file, pull down Assets, click on Create again, click on Material again, and call the second one Nose Red, NOSERED. And just make sure that the two new materials that you've just created, iBlack and Nose Red, are indeed in the Materials folder inside the project pane at the bottom left hand of the screen. Right, so the next thing we want to do is select iBlack within the Materials folder, the bottom console area of the screen, and then we want to navigate up to the right hand side of the screen where it says Albedo, and next to Albedo there's a white rectangle there. We want to left click on the white rectangle, and that will open up a palette of colors from which we can choose. And what we want to do is within the palette of colors we want to choose black. Now we want to go back down into the left hand bottom side of the project. We want to click on Nose Red and then go up onto the right hand side under the inspector by Albedo. We want to again select that white rectangle, which will open up the colors, and here we want to choose a red color for the nose. Okay, now in the hierarchy we want to select shades, so left click on shades, and then on the right hand side of the screen under the inspector you'll see a mesh renderer section which says element 0 and it says default. What we want to do is click on the small circle just to the right of element 0 where it says default material. So that little small circle, and we want to open that up, and you can see there's a number of selections to be made, but what we want to do here is select iBlack. And so you should see that the robot shades now are black. Next, we're going to go into the hierarchy and left click to select nose. And then in the nose, we're going to go over to the right hand side into the inspector, and under mesh renderer, under materials for element 0, where it says default material, we're going to go ahead and click on the small circle on the right hand side again. And this time we're going to choose select Nose Red. And now your robot should have a red nose. If for any reason you're having trouble seeing the black shades or the red nose of your robot, if it all appears a bit gray, go up to the scenes area and make sure that that light bulb icon is switched off. When it's toggled off, the light attached to the scene view camera is used. When it's toggled on, the scene lighting is used. So it might be a little bit clearer to see the colors with the light bulb toggled off. So the next thing we need to do for our robot is we need to give our robot some rules. What we need to do is create a component so that we can move the robot about and let the robot interact with the world. And the component, we're going to call it a rigid body component. So what we're going to do in the hierarchy, we're going to left click on Maze Robo to select our Maze Robo, and then we're going to click on up at the top Component, pull down menu, Physics, and Rigid Body. And then this will let us set rules for how the maze robo behaves in this game. And what you'll find now is that when you have Maze Robo selected, on the right-hand side of the inspector, you'll see that there's now a rigid body section in that inspector. So in the inspector section, if we scroll down to the rigid body section and open up the constraints subsection within the rigid body section, we'll see that there's freeze position constraints and also freeze rotation constraints. For freeze rotation, we want to tick on the box next to X, tick on the box next to Y, and tick on the box next to Z. And so what that does is it sets the X, Y, and Z rotation conditions to true because we've clicked in all the boxes. And then the next thing we want to do is in the freeze position, we want to just tick in the Y box. So we want to tick the Y box, set it to true, so that the constraint of the robot is that it will freeze in position Y, but not in X or Z. So this completes the setting up of our basic robot character. Now we're going to go ahead and work on making the ground under the robot. Okay, to start setting up the ground plane underneath the Maze Robo for it to move around on, what we're going to do is go up to the Game Object pull down menu, and we're going to choose 3D Object, and then we're going to choose Quad. We're going to change the name of the object from Quad to Ground in the inspector. Next thing we're going to do is go down into the Transform section of the inspector, and we're going to set the X rotation to 90. And for scale, we're going to enter an X value of 40.96, a Y value of 40.96, and a Z value of 1. And we're going to want to make sure that in our transform, our position is X of 0, Y of 0, and Z of 0. So you can see in the scene area that the ground is now the orange rectangle. And you can see as I move the ground around in relation to the robot, you can see that the robot is actually stuck halfway into the ground. Half of the robot body is above the ground and half is below the ground. Well, we don't want that. We want the robot to be completely above ground. So we're going to have to go ahead and go in and fix our robot's position coordinates so that it's completely 100% above ground. So we're going to click in the hierarchy area. We're going to left click on our Maze Robo again, and we're going to go into the position area under Transform, and we're going to change the position coordinates of our Maze Robo to X of 0, Y of 1, and a Z of 0. And now when we move the ground around, you can see that now it's completely under our robot. Instead of half of our robot sticking out, it's completely 100% below our robot body. And now that we've created our ground, we're going to go ahead and add a wall. So we'll go up into Game Object again, top menu, Game Object, 3D Object, select Cube, and then in its inspector, set its transform position to an X of -2, a Y of 1.5, and a Z of 0. And then we're going to go down in the transform area from position down to scale. We're going to leave the X at 1 and the Z at 1, and we're going to change the Y value to 3. And then we're going to go up to the top of the inspector where it says cube, and we're going to rename the object from cube to wall. All right, so we're going to want to take our new wall that we just created, and we're going to want to give it a color. So select wall with a left click on wall, and then pull down the assets menu at the top, assets, create materials. and we want to rename the material wall blue, WALLBLUE. And then make sure that wall blue is selected down in the materials section, and look over into the inspector on the right hand side to the albedo. Again, left click on the white rectangle to pull up the color palette and choose a nice blue color to color in your wall. And then to finish coloring your wall blue, select wall in the hierarchy, left click on wall, and then go over to the mesh renderer, and in the materials section where it says element 0 default materials, select on the right hand side that small little circle, and then select within that tool that opens up your wall blue material, and that should turn your wall to blue. Okay, so next we're going to work on making the robot move. So here we're going to start actually writing code so that the player of our game can control our robot. So what we want to do next is go into the project pane and click on the assets folder. And then once the assets folder has been selected, go to the assets pull down menu in the top left, select create and select folder. And we're going to want to rename our new folder scripts, SCRIPTS. So we're going to start writing some scripts to get our robot moving. And we're going to be writing our Unity scripts in a language called C#. And it's basically represented by a C followed by a hashtag symbol. So now we're going to create a new C# script. So we're going to go up into the Assets pull-down menu, select Create, and then select C# script. And then what we're going to call the C# script, we're going to call it RoboMover. And then so under Asset Scripts, left double-click on RoboMover. And what it's going to do is there's going to be a pop-up to ask, how do you want to open this file? And you've got, and here you can choose WordPad, but I've also downloaded a script editor that I like and like to use. So I'm going to select it. It's called Sublime Text 3. So that's something I've downloaded. So I'm just going to select Sublime Text. And when you select the text editor, it'll bring up the C# code within the text editor as a pop-up. And if you accidentally close your text editor, you can reopen it in the inspector and the top section, the RoboMover import settings. There's an open button, and that will open up your text again in the text editor that you've just chosen. So let's go over what the C# code is saying. Basically, the first 3 lines is just the program setting up the things it needs to run. And then you've got a line that says public class RoboMover : monobehavior bracket. That's basically the start of a class, which is a blueprint of code called RoboMover. Everything in between the first bracket and the last bracket is going to be inside of the RoboMover class. Then below that, you've got 2 function declarations, and the names of the functions are called start and update. And a function declaration is basically where a function gets defined in your code. The functions right now are both empty. The only difference between them is their names. One is called start and the other is called update. The round brackets that are located beside the name are empty, but those round brackets can be used to pass information into the function, whereas the curly brackets below the function name are used to set out what the set of instructions are that the program will follow once that particular function is called for in the program. So that's just a quick overview of the code so far. So we're going to add some variables to our code. We're going to add them inside the class RoboMover, but before the functions of start or update. So we're going to create three variables. The first one we're going to call move speed. The second one is called RB, which refers to rigid body. And the third one we're going to call TF, which we're going to use to refer to the transform. So RB for rigid body, TF for transform. And the move speed is just the speed of moving. It's going to be a decimal number. And in this case, we're going to set it to be 4.0. And we're going to go ahead and delete the start function in this program. So the lines that refer to the start function, we're just going to go ahead and delete those lines. So next thing we're going to do is go down to the update function, and in between the curly brackets, we're going to type some new lines of code. Now the first new line of code, the first line of the function basically creates a desired direction. It's a set of three coordinates, two of them which are taken from the input, which is the direction the game receives from the player. So the player is going to be clicking on arrow keys on the keyboard, and that's going to determine two of the coordinates that the robot is going. It's going to determine the direction of the robot. The third coordinate is the depth of the character, and that's something that the user is not going to be changing when they click on the arrows. So we're just going to set that to 0.0. Then in the next line, what we're going to do is we're going to multiply the desired direction by the move speed, which is the variable that we set earlier, which controls the speed that the robot moves. So next we're going to multiply our desired direction again, and this time we're going to multiply it by delta time, which is the amount of time since the last time update ran, so that the direction changes no matter what type of computer we're running our game on. And the last thing is we're going to change the position of the robot, the rigid body of the robot, by the amount that we've calculated, and then we're going to store that in the desired direction variable. And so what does this all mean? Basically, what this all means is that every time the screen is updated, the character is going to move a tiny bit in the direction that the player is sending it with the arrow controls. Make sure after you do a lot of work that you save. So in your text editor, click the file drop down and hit save, and then go back to your Unity screen and also file drop down and save. Make sure you save your work as you go along so you don't lose it. Okay, so the next thing you want to do is take your C# RoboMover script from the script selection, select it and drag it and drop onto the maze robo in your hierarchy up in the top left. And after you've done that, you clicked and dragged your RoboMover onto the maze robo game object within your hierarchy. You should now see in the inspector on the right hand side below rigid body, you should now see a new section which says RoboMover Script. And in the RoboMover Script section, you'll see that there's an RB which says none, rigid body none, and then there's a TF which says transform, which also says none. So these are empty fields so far. But what you want to do is you want to click and drag the names of these components from up above, from their places in the inspector and into their respective fields. So first we're going to start with rigid body. So we're going to drag rigid body, drag it down. So we select rigid body and we drag it down into the RB field. And then we're going to do the same. We're going to scroll up to transform, drag transform from within the inspector, drag it down to the TF field. And then you can see now RB and TF within the script sections both have something in them now. Okay, so now we're ready to test our code. So what we want to do is go to the top middle section where we've got the play button, and we're going to want to click on the play button. And then we're going to want to click our arrows. So you want to click on your arrows, your up, down, left, and right arrows on the keyboard to move your robot around the screen. And what you might have noticed right away when you're moving the robot on the screen is that no matter which area you click, the robot is never facing you with the shades or the nose. The robot is always facing away. So the next question is, well, how do you move the robot properly? How do you move it so that it sees where it's going? So the next thing we're going to do is we're going to fix the code so that the robot can see where it's going. So we're going to go back and we're going to double left click on the RoboMover script again, and that should pop up our text editor immediately. And now what we're going to do is we're going to add a new line into the code directly below the RB.movePosition line. And this line of code is going to make the robot look to see where it's going. So now we're going to hit the play button again and just test to see if it works. We're going to hit the arrows again. You can see now it is the robot is facing us. However, when we click off the robot, it turns around again suddenly. You know, we weren't expecting that. We weren't expecting the robot to spring back into looking at its original direction. You'd expect it to continue facing in the direction it was moving. So we'll need to fix that as well. So once again, double click on the script RoboMover. So in order to fix this, what we're going to do is wrap all of our existing direction change code into an if statement. And the if statement only runs the code inside it if the condition within the brackets is true. So we're going to have the if statement check to see if the input horizontal is greater than 0.01 or if the input vertical is greater than 0.01. And an or is basically, to represent or in this language, we use two pipe characters between two conditions. So it's condition A and then two pipes and then condition B. And in the input horizontal and the input vertical, you will have noticed that we're comparing it to absolute. So it's math f dot abs. So we're looking at absolute. So we're looking at whether it's a positive number or a negative number. We're just looking for anything positive or negative that's greater than 0.01. So that's why we've put an absolute in either the input horizontal or the input vertical. So we're going to have the if statement check to see if the input horizontal is greater than 0.01 or if the input vertical is greater than 0.01. And an or is basically, to represent or in this language, we use two pipe characters between two conditions. So it's condition A and then two pipes and then condition B. So those two vertical lines is called the pipe characters, and that basically means it's either seen if the input horizontal is greater than 0.01 or if the input vertical is greater than 0.01. This will ensure that once the player starts hitting arrows, the robot's turning direction will follow its movement and stay attuned to its movement. It won't flip back to the initial setting of the game. Only when the game starts again will the robot face back to the default setting. So here, once again, we're going to hit the play button to test. And I'm going to hit the arrows left, right, up, down, watch. And make sure that the shades and nose are always facing in the direction which we're pointing, even if we stop. And once you're done testing, hit the play button again to stop. And then remember, as always, to go into the file pull down to save your code before you close the Unity system, before you close the Unity software. Right, so thank you for watching. We've now got our robot moving. Next week in part 3, we'll work on camera tracking. We'll also go ahead and work on giving our robot something to play with. So please stay tuned for next week to learn more about our robot in 3D animation with Unity.